Back to my channel Reagent. In this video I'm going to discuss about how to construct a galvanic cell for a given redox reaction, and also we discuss representation of a galvanic cell, or what we call that cell notation. Sometimes students get confusion writing cell notation for a given redox reaction. In this video, I'm going to explain in detail how to represent galvanic cell for a typical redox reaction. As you know that galvanic cell is made with two half cells which work independently. So left half cell and there is right half cell. Both half cells work independently. In the left half cell there is oxidation takes place on the electrode of the half cell, and in the right cathode there is reduction takes place. The electrode taken in the left half cell is called anode, whose sign-up convention is negative for the electrochemical cell. Of course, in electrolytic cell it is positive, and in case of cathode sign-up convention is negative, we say, and in case of electrolytic cell it is positive. And both left half cell and right half cells both are joined by salt bridge. Already we discussed salt bridge which maintain electrical neutrality. So in galvanic cell there is reaction. That reaction is redox reaction, we say, which is a combination of oxidation and reduction. So both are oxidation and reduction reactions are coupled to each other, hence it is said to be a redox reaction. So typical galvanic cell is already you know Daniell cell, and in this Daniell cell left half cell is pure zinc metal placed in zinc sulfate solution, aqua solution, and in the right half cell we take pure copper metal in copper sulfate solution, aqua solution we take. That means in the left half cell we take pure zinc metal placed in the zinc sulfate solution. Metal is placed in the salt solution, and in right half cell there is copper metal placed in the copper sulfate solution. Both are joined by the salt bridge. Already you know, in this Daniell cell, what is a redox reaction that takes place when we join these two half cells through a wire and voltmeter. So what redox reaction that takes place in the galvanic cell is that zinc metal means solid placed in zinc sulfate solution. The redox reaction I am writing complete redox reaction. Zinc plus copper sulfate solution, aqua solution. Zinc react with the copper sulfate solution to form, so zinc sulfate solution, aqua solution I am writing, and copper metal is formed. So this is the redox reaction that takes place in the Daniell cell. So how we get this? Yeah, actually, so half cell and left half cell and right half cells are separated. We take these in separated containers, and both are connected through wire and voltmeter. So then the EMF will generate, and potential difference will generate because of this reaction. So, and how this is the redox reaction that takes place in the Daniell cell. And how we get this reaction, now let me discuss. So if you observe this typical redox reaction, zinc metal placed in copper sulfate solution, and we get zinc sulfate and copper metal. In this reaction, we divide this reaction into two half cell reactions. One is oxidation half cell reaction, and other one is reduction half cell reaction. So now here is zinc metal whose oxidation state is 0, and it oxidized to form zinc plus 2, and lost how many electrons? 2 electrons. That means here zinc metal getting oxidized. So we can write the reaction is zinc get oxidation to form Zn plus 2. So which is called oxidation. And in another half cell, there is a copper ions get reduction by gaining electrons and become into copper metal solid form. This is reduction. So now we write both half reactions. So both half reactions I am writing. Zinc solid changes into Zn plus 2 ions aqueous form to get 2 electrons. At the same time, cupric ions aqueous solution present in the aqueous solution get reduction, gaining 2 electrons to get copper metal solid. So if you combine both reactions, so zinc solid placed in copper's aqueous solution ions, so 2 electrons cancel, and you get zinc plus 2 aqueous solution plus copper solid. So we get the complete redox reaction. The first reaction, this reaction takes place at anode, this reaction takes place at cathode. So here I am writing anode, at the anode, and at the cathode, right? At anode and cathode, and this is complete redox reaction. So complete redox reaction, zinc changes into Zn plus 2, cupric ion changes into copper. So this reaction is spontaneous, and this reaction produces cell potential is how much? It is around standard cell potential 1.10 EMF. So now here this reaction, redox reaction, can be represented in the form of electrochemical cell, in the form of galvanic cell, So I am writing cell notation or cell representation. As you know that a Daniell cell or a typical galvanic cell made up of 2 half cells. Now I am taking left half cell. In the left half cell, zinc metal, pure zinc metal is taken in the form of solid. So which is separated by zinc sulfate solution, aqueous salt solution. This is a liquid, this is solid, separated by vertical line. Liquid solution interface with the solid metal, pure solid metal, shown with the vertical line. And in another half cell, cupric ions, aqua solution, present in aqua solution, separated by copper metal, pure copper metal by the vertical line. And these two salt solutions, electrolytic solutions, are separated by salt bridge, which is indicated with two vertical lines. So this indicate salt bridge. And always in a galvanic cell or typical galvanic cell, so LHS will be the anode and RHS will be the cathode. Cathode will take. So here zinc changes into +2 ions. There is oxidation. And copper get reduction to form cupric metal, copper metal. So here is reduction. So oxidation and reduction. In the left half cell there is oxidation, in the right half cell there is a reduction taking place. Both are separated by salt bridge. So, and when zinc changes into zinc +2 ions, cupric ion changes to copper metal. During this reaction, EMF or standard cell potential generated, which is equal to 1.10 volts. 1.10 volts. So how this cell potential is a positive, and if you want to know whether this cell potential is positive or negative, whether the cell work or not, does the cell function as not, if you want to check, then we have to calculate cell potential. We have to calculate standard cell potential. So by the formula, so I am writing the formula of cell potential. So whether this cell notation or cell representation, correct or wrong, can be identified or can be calculated by using the formula standard cell potential. Formula is equal to E cathode, electrode potential of the cathode, standard electrode potential of cathode minus standard electrode potential of the anode. The difference of the electrode, standard electrode potential of cathode and anode, is the cell potential of any electrochemical cell. So now, so what is here I am writing E naught cathode. At cathode, what is happening? Cu +2 getting reduction to C minus standard electrode potential of anode, Zn +2 getting reduction to zinc. Here actually oxidation is happening. We are inversing that. So inverse of the oxidation reduction I am writing. So now here is the standard reduction potential of copper. How much? It is 0.34 volts minus standard reduction potential of zinc is minus 0.76 volts. So minus plus, you get the value is around 1.10 volts, which is positive. Cell potential is standard cell potential is positive 1.10 V. So which is cell potential is a positive, means cell reaction is spontaneous and cell easily can operate. So the cell can work efficiently. So, and this is a representation of galvanic cell. Thank you.